is pulse width modulation, or PWM for short. Understanding PWM on a fundamental level can and will help you diagnose issues correctly and avoid unnecessary parts replacements. PWM is used throughout the vehicle to control a ton of components. Common examples include fuel pumps, cooling fans, blower motors, turbo actuator valves, variable valve timing solenoids, EGR valves, LED headlights, and interior dimming circuits. Pulse width modulation is a method of controlling a circuit or component where voltage is switched on and off rapidly, rather than reducing the voltage to slow a motor or dim a light, for example. The control module sends full system voltage, but adjusts how long it stays on versus off each cycle. This ratio is known as duty cycle. Duty cycle is represented as a percentage value. To put it simply, it is a percentage of time that the circuit is being supplied 12 volts. If you have 50% duty cycle, it means that 12 volts is being supplied half the time. Conversely, if you have a 90% duty cycle, 12 volts will be supplied 90% of the time. This on and off time allows you to control average voltage output and therefore current, resulting in fine control of speed, pressure, and/or brightness. Duty cycle is not to be confused with frequency. Frequency is how fast or often one of the on-off cycles occurs per second. For example, here is an on-off cycle, and here is another. As you can see, they both have a duty cycle of 50%. That is to say they are both on half the time, but that cycle occurs much more often per second in this example, meaning it has a higher frequency. Frequency can be used to control the smoothness and operational characteristics of a component, but not its power supply value, and therefore any output capacity of a component. Typically, you will only be concerned with duty cycle value, but it is helpful to understand the difference. You may be thinking this is all great and everything, but it seems more complicated. Why do we use this system? PWM has a variety of advantages over older analog control methods. The main one is efficiency and control. PWM allows modern vehicles extremely fine control over precision components and allows components to run cooler. It also allows low current control module to control a high current load via internal drivers and/or transistors. You can kind of think of it how a relay allows us to control high current components with low current control modules. When diagnosing PWM circuits, we're mainly trying to confirm three things. Firstly, that the control module is outputting the correct duty cycle, that the signal is reaching the load, and lastly that the load is responding relative to the duty cycle. For example, if you have a 90% duty cycle out of fan, it should be almost full blast. And if you have 10% duty cycle out of fan, it should be barely on. To do this correctly, you must use an oscilloscope. This is one of the only ways to accurately confirm duty cycle waveforms, as it will show you duty cycle, frequency, and waveform shape and quality. You can infer based on the voltage average on a multimeter, but this could really bite you in the butt and send you down a rabbit hole. I even have a multimeter that displays duty cycle, and I rarely ever use this approach. PWM is now a staple of automotive systems, and taking the time to understand these systems and acquire the correct tooling will only make your diagnostics and testing that much faster and accurate.